Today we are going to complete pages 1 and 2 in our math notes, and the title for that page is going to be Symmetry. So make sure you fill out both the table of contents sheet, and when you flip to page 2, I want you to make sure that you add in your page numbers, page 1 and 2, and you title the top of this page Symmetry. So we know that there are two different kinds of symmetry: lines of symmetry and rotational symmetry. Remember that anytime during the video today, you can pause the video and copy the notes and then start the video again if I get ahead of you. Let's zoom in a little bit here for us. See exactly what's going on. All right, so a line of symmetry is a line that divides a 2D shape into two matching halves when the shape is folded. So that's one kind of symmetry. The other kind of symmetry is rotational symmetry. And a shape that can fit exactly onto itself more than once in a complete rotation has rotational symmetry. So if it rotates 360 degrees all the way around and never lines up with itself that whole time, it does not have rotational symmetry. It has to fit more than one time in that 360 rotation. So you picked up a sheet of pink shapes today. Sheet like this, and your first task is to take a minute, pause the video, and go cut out all 6 of those shapes, and then come back and we'll keep working. All right, I already have that done. And so looking at the very first shape, we are going to start with the trapezoid. And if I fold my trapezoid in half, I notice that it can line up exactly in two matching halves. So we could say that this trapezoid has one line of symmetry, and I went ahead and put a dashed line on that line of symmetry so I could see it. And then go ahead and take either a piece of tape or a glue stick and glue that shape into your notebook. So if we are looking at our trapezoid, although it has one line of symmetry, what I want you to do is put your trapezoid on your paper and then go ahead and trace around the outside of your trapezoid, and then use your brad to push through and attach that shape to your paper. That way you can see that as I rotate this trapezoid around, it does not have rotational symmetry. Never does it line up with itself as it rotates around. So this trapezoid does not have rotational symmetry. The next shape we're going to talk about is the square. And the square has 4 lines of symmetry. I can fold it vertically, I can fold it horizontally, and then I can fold it diagonally, either right to left or left to right. So I went ahead and put dashed lines. After I'd folded it, I put dashed lines on all 4 lines of symmetry so I could see them. And then I put a little piece of tape in the upper left-hand corner so I could still fold it up, but that'll hold it into your notes for you. And then I would recommend, before putting your square into your notes, that you locate the center of your square for putting your brad through the center, both on your paper and on the pink square that you're going to attach to your notes. And you'll see why as you see mine rotate. So I went ahead and put mine in, and then I marked where sort of the one side of my square was lined up with each other. And notice that as I rotate my square, that if I rotate it 90 degrees, my square lines up with itself again. And if I rotate it another 90 degrees, now I've rotated it a full 180 degrees, and my square lines up with itself again. And if I rotate it another 90 degrees, my square for the most part, lines up with itself. So you'll see that I did not find the exact center of my squares, and so it doesn't line up perfectly, but it's an example. You can see that it would line up. And if I rotate it a final 90 degrees, I'm back to where I started, and I've gone 360 degrees. So the square has rotational symmetry of 90 degrees. That means that every 90 degrees it's going to line up with itself. All right, so our last shape is our parallelogram, and our parallelogram has no lines of symmetry. No matter how I would fold this shape, it will not line up with itself. So it has no lines of symmetry. Make sure that you lay out your parallelogram and trace around it again, and try to find the center so that when you rotate you can see if it lines up. And I marked where my starting point was. And so as I rotate 90 and then 180, notice that at 180 degrees I am now back to my original shape. It's lined up matching my original shape. And if I rotate another 180 degrees, I'm back to my original shape. So the parallelogram has rotational symmetry of 180 degrees. All right, so on page 1, I have two short things that I want you to complete. Make sure that you have your page number listed, and then I want you to copy both of these directions. First, I would like you to draw an example of a shape that has 3 lines of symmetry. So in this space, you're going to find a shape that has 3 lines of symmetry and draw it there. And then I also would like you to find a shape and draw an example of a shape that has rotational symmetry of 60 degrees. That means that if you rotate 60 degrees, you will be back lined up with your original shape. And go ahead and draw a copy of that in your notes, and then you will be done for the evening.